The topic we will be discussing in this session is IPv6, that is IP version 6. Mobile IP was actually developed for IP4, but IP version 6 simplifies the protocols to a larger extent. For example, security is integrated into IP version 6. It is not an add-on feature, whereas for IP version 4 it is an add-on feature. Authentication of registration is included in IP version 6 as a default one. That is, any mobile node, whenever they move away from their home network, it should register with the foreign agent, and that information should be updated to the home agent also. That process uh, is already a part of IP version 6. And in IP version 6, COA, that is the care of address, can be assigned via auto configuration. Care of address can be assigned through DHCP, Dynamic Host Configuration Protocol version 6. Okay. So every node has address auto configuration feature. Every node has the address auto configuration feature. So so they so and all routers can perform routing advertisement. All routers can perform routing advertisements. So so the nodes has auto configuration facility, and every node can perform routing advertisement by themselves. So there is no need for a separate FA. There is no need for a separate FA which sends beacon signal, and then the mobile node will register. Such operations are not required in IP version 6, but they are part of IP version 4. Okay, so so these are some of the main features of IP version 6. And then addresses in IP version 6, the mobile nodes addresses are always co-located. That is, mm, so two types of COA we have discussed. One is co-located COA, and the other one is the COA located in the foreign agent. But with IP version 6, all addresses will be co-located. Okay, and the mobile node uh, can signal a sender directly the COA. The mobile node can respond to any node directly with the COA. Okay, sending through HA is not required. You need not send the information to through home agent. It can the mobile node itself can directly communicate the information. Uh, uh, the mobile node itself can signal a sender directly the COA. Okay. So a mobile node itself can communicate with anybody. It need not go through HA. And this allows for authentication, or this allows for automatic path optimization. And also it supports many soft handover. It also supports soft handover features. Soft handover means the mobile station is moving from one network to another network without call drop. That is called a soft handover. If there is a drop of if the call got dropped during that time, then that is called as hard handover. So IP version 6 basically it supports soft handover. There is no packet loss due to change of subnets. If the mobile node is moving from one subnet to other subnet, because of that there will not be any no packet loss will be created due to that. Okay. The mobile node sends the new COA to its old router. Whenever the mobile node what do you call whenever the mobile node goes to a new network, it will get a new COA, but that new COA also it will communicate to the old router, because some packets may still come to the old router if other nodes does not know about the current location of the mobile node, and then these routers can route the packet to the new COA. Okay. The old router encapsulates what the old router will do. It encapsulates all incoming packets for the MN and forwards them to the new COA. Right? COA is care of address. Now COA is it is located in the mobile node itself. Okay, that is uh, uh, that is basically it is a what do you call? It is the COA will be available in the uh, mobile node itself. That is, it is a co-located COA. Okay, so that's it about IP version 6. The next concept that we'll be discussing is IP micro mobility. So what is meant by micro mobility? See, mobile IP exhibits several problems regarding the duration of handover and the scalability of the registration procedure. Okay, assuming a large number of mobile devices changing networks quite frequently, a high load on the home agent as well as the network is generated by registration and binding update. If there are many nodes and they are changing from one network to another network, then what will happen? There will be many registration will be going on, and there will be many binding update will be going on. Okay, so so the IP micro mobility protocol can help the mobile IP by offering fast and seamless handover in limited geographic area. That is, when the mobile node is moving in a limited area, that everything need not be updated to the HA, home agent. Okay. Whenever the mobile node is moving beyond a certain geographical area, only that should be updated. Otherwise, updating every small information to the HA, it will become a overhead for the HA. Okay. So, but anyway, then even though if the mobile node is moving within the small geographic area, then also you should track it. So that can be done by using a protocol that is called as IP micro mobility protocol. Okay, IP micro mobility protocol, right? So one of the example is, assume a student changes subnets on the campus frequently. That is, he is not going out of the campus. Student is not going out of the campus, but within the campus he is changing the subnet. Okay. Now the question is, whenever he changes the subnet, is the HA should be informed every time about his precise location? Is it required or not? Generally, without micro mobility, whenever he changes the subnet, HA should be updated, and his precise location should be updated in the HA. But if micro mobility feature is there, then then whenever there is a local handover means within the campus, whenever the student is moving from one network to another network, that need not be updated in the HA. Rather, there will be a router in the local network that will take care of that. Okay, and any packet to this particular mobile node who is in this campus network will not be sent directly to that particular node. Rather, it will be sent to the main router. Okay, and from there it will be sent to that particular mobile node. So this router knows where the mobile node is currently. Within the campus only he is available, but he may be in some other subnet. So it will route it. Okay. So basically it provides efficient local handover inside a foreign domain without involving a home agent. So that is what micro mobility does. And it reduces control traffic on backbone. So what happens? The traffic, the control traffic of the backbone system will be reduced. Okay. So it is especially needed in case of route optimization. So there are a lot of research is going on this area. People are developing different products, but there is no standardization yet. So there are other security issues also with micro mobility feature. There is a efficient how security will be can be efficiently provided, how scalable it is, how transparent it is, how manageable it is. All these are the issues of micro mobility support of IP. Okay. So basically, micro mobility in the sense when the mobile station is moving within a limited geographical area inside a particular network, that inside a particular main network that need not be updated to the HA. But in that local network, there will be some router. So whenever the HA want to communicate, whenever any user want to communicate with the mobile node within this particular foreign network, They will just send the data to the main router, which is responsible for this network. That router will in turn will take care of the local mobility. That is, if the user has locally moved from one what you call one subnet to other subnet, this router will identify and it will forward. Okay, so this concept is called as micro mobility support, IP micro mobility support. Fine. So next we shall discuss one example for IP micro mobility. So this concept is called as uh, hierarchical mobile IP version 6. So it is also called as HMIP v6. So, so this is an example. Basically, this is an example for IP micro mobility support, and this concept is called as hierarchical mobile IP version 6. Okay, it is hierarchical mobile IP version 6, and it is shortly it can be represented as HMIP, is hierarchical mobile IP version 6. Okay, so shortly it is represented as HMIP version 6. Okay, so network contains the main network. So whenever any network will have something called as mobile anchor point. So you can see here there is a mobile anchor point, and this mobile anchor point will be associated with an RCOA. Okay, which is regional COA. Okay, RCOA stands for regional COA. That is regional care of address. So this mobile anchor point will have an RCOA that will be responsible for this entire region. Okay, and so and there are many access routers. So AR represents access routers. These access routers, what they will do in the sense, they will the access routers define the boundary of MAP, mobile anchor point. They define the boundary of mobile anchor point by advertising the MAP information to the attached mobile nodes. So basically, these ARs they define the boundary of mobile anchor points by advertising the mm, details of MAP. Okay, by advertising the uh, details of MAP, they define the boundaries of MAP. Okay, so this is what this AR does. Okay, right? And to this AR, you can see there are many YAMNs attached. So for so the mobile node, currently assume that there is a mobile node. There is a mobile node which is normally registered with a home agent or a home network. Consider this mobile node is moving to a foreign network. So this is that foreign network. So in this foreign network, so the foreign network is mainly accessed through map. Okay, mobile anchor point. The in mobile anchor point it is accessed through RCOA, regional COA, and the boundary of the regional COA will be defined by AR, that is access routers. They advertise the map information to different MNs. The mobile node will be connected to any one of the AR. Mobile node will be connected to any one of the access routers. Okay, so so this is how, if any information is to be sent to a mobile node, this is how it will reach that particular mobile node through a particular access router. It will reach. Okay, now this mobile node will have a LCOA. This mobile node will have an LCOA. LCOA stands for local care of address. LCOA stands for local care of address. Okay, so, so let us assume that initially the mobile node is connected with this particular AR. Initially the mobile node is connected with this particular AR. At that time, it will have an COA, care of address, which is called as LCOA old. It is called as LCOA old. Okay. But later, say Say after some amount of time, the mobile node has moved from this AR to this AR. So it means this is one geographic area. This is one geographic area. This geographic area is controlled by this access router. Okay, so it is in with this AR, but later after some times, it has moved to some other AR. So when it has moved to the new AR, what will happen in the sense, automatically it will be allocated with a new LCOA, new local care of address. Okay, so it will be automatically provided with a new LCOA. Okay, so uh, so so whenever so 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 whenever there is a handover, so this is something called, this is a handover, because this is a local handover. The mobile is moving from one access router to another access router. That is a local handover. Okay, so a map assists with MAP. MAP stands for mobile anchor point. A mobile anchor point assists the local handover and maps RCOA to LCOA. Okay, so this local handover will be taken care by the MAP. Say now there may be some packet coming from outside for the mobile node. Now map knows that where this mobile node is. Now it knows that it is connected with this AR. But if the same packet has came, if it has came before sometimes, then at that time map knows that the mobile node is connected with the this particular AR, and the mobile node is identified with this particular COA, LCOA old. Okay, but currently it is identified with this LCOA new. So this local handover, it will be taken care by map. Okay, so that is the point. Okay, but assume that the mobile node is moving beyond a particular geographical area. Okay, if the mobile node is moving beyond a particular geographical area, this if it is moving beyond this particular map, then in that case the mobile node will register with the HA. In that case, the mobile node will update the HA. That is, I'm connected with some other map. Like that, it will update the HA, and that map also will inform this particular map. Okay, so that if there is any packet sent to that particular node, it will this map will send to the new map. Okay, it is this mobile anchor point will set to the new mobile anchor point. So here, whenever the mobile node switches from one one access router to another access router, automatically the mobile node will give a binding update to mobile anchor point, so that the mobile anchor point will be knowing the new COA of the mobile node, right? So this is how the IP micro mobility support works. Okay, HA is contacted only if MAP changes. Okay, that is only if the mobile node moves from one map to another map. Then only it will be registered with HA. Then only HA will be updated. Otherwise, any local changes that will be taken care of by the mobile anchor point itself. So, mm, so there is no HMAP specific security provisions. There are no specific security provisions were added here. Okay, and the advantage of this technique is the local COAs can be hidden, which provides some form of location privacy. Okay, that is, if a user want to know communicate with the mobile node, the local he need not know the local COA. It is enough if he know the RCOA, regional COA. With that, he can communicate. So it includes some level of privacy. Okay, and direct routing between CNs sharing the same link is possible. Okay, direct route between two correspondent node is possible, but it is dangerous. Okay, handover requires minimum number of overall changes to the routing tables. Okay, the changes are not much. It's quite minimal. There are some problems also. The problem is decentralized security critical functionality, handover processing in mobility anchor points. That is, whenever a mobile station moves from one one I mean one AR to another AR, that information is sent by the mobile station itself. So just we are believing the mobile station. So this itself is a potential security issue. Okay. Mobile nodes can directly influence routing entries via binding updates. Yes. So whenever the mobile node moves from one AR to another AR, one access router to another access router, it will send a binding update, and based on that binding update, the routing table is getting updated. Okay. So somebody else for attacking purpose also they may send a binding update pretending to be some other node, and they may change the routing table. Okay. So these are the potential problems that may happen with this technology. Okay. The first problem is decentralized security. The security is not centralized; it becomes decentralized. A critical functionality in mobility anchor point. For example, handover processing is done by the mobility anchor point. Okay, so so HA is not doing that. So it means we are believing on the mobility anchor point. So that there also some risk is involved. Okay, so and it is not transparent to mobile nodes. Is not transparent to mobile nodes, right? So so this is about IP micro mobility support, right? That's it. We'll stop here. Thank you.